Okay, so hello.
This meeting is being recorded.
Yes, it's being recorded. And welcome everybody. Thank you for joining. Today is June 15, kind of middle of the year of 2022. This is SIG API Machinery Kubernetes bi-weekly meeting. We are starting our meeting. We have an agenda. I see that Shyam joined just in time, so maybe we can start with your topic and then we go with Kevin's. So Shyam, is that okay with you? All yours.
Hey, thanks. Sorry, I was late. I had some issues with my Zoom.
No problem.
So yeah, I wanted to bring this up a couple of weeks ago, actually. So today we do Gzip compression of the API responses. I think many of you would already know about this, and I think the criteria we do this under is the if the response is at least 128 KB, and the client explicitly says that it accepts Gzip encoding. We do this for resource type APIs, so we don't do streaming ones like watches and stuff. Sorry, for exec logs, proxy and stuff like that. So one of the things which I've seen, I've been trying to run some experiments around this is, so the returns of Gzip, so when you do Gzip, you're essentially trading for network, right? So you're trying to basically spend some extra CPU cycles both on your server side to compress the response and also on the client side to decompress. And as a result, you're reducing the size of the response that you're sending over the wire. So it reduces the network bandwidth. So you're saving time on network transmission, but you're spending time on CPU, on compute. So depending on which one wins, it can either be a beneficial thing or something which actively hurts us. So what I've seen in some of the clusters that we manage is actually the amount of time. So in the API call latency, there's a big part of response compression, especially there's a big part of this Gzip compression in the latency. So for example, I've seen calls, especially like when you're listing things like secrets and config maps, where you list all the objects from etcd in 2-3 seconds, and then it takes, so from the traces, you can see that it takes 30-35 seconds to write the response. So I tried to dissect it, I tried to disable Gzip and see that it falls down pretty rapidly. So again, it's particular clusters, right? I'm not commenting on like a generic cluster out there. But yeah, sorry, Danny.
So sorry for interrupting.
Yeah.
Have you looked at like just how loaded in general the cluster is? Because I think that that's something that really shouldn't be slow unless the API server is under compute pressure, like CPU pressure already, which makes me think that maybe a better thing to configure, like that's going to hurt API server performance just in general. So perhaps a better thing to think about is just configuring QPS or your priority and fairness settings just in general to make sure the API server is only getting a load that it can reasonably handle.
Yep. So what I actually observed was these instances are not under CPU pressure, Daniel, because they are pretty big instances, and like the CPU usage was less than like 50 or 60%. So and if I'm understanding this right, the way this Golang, like the Gzip, maybe I'm understanding this wrong actually, but the Gzip, it's done as a single threaded. So for a single response option, for a single response object, the Gzip compression is done single threaded. So if you're not under CPU compression, still you're rate limited by the rate at which compression actually happens. So if it's a big response, then so in this case, they were actually, I think, bigger responses because they were not paginated calls, which in general is a bad idea. But for the
I mean, in general, you're going to have a like I'm not sure, because if you've got an enormous response, API server doesn't stream like an unpaginated list, say. API server doesn't stream things out as it comes in. It builds up the entire response in memory and then sends it all at once. So I mean, I think that's going to be bad whether or not you're compressing it.
I mean, the Gzip aspect is streaming. So you're right, Daniel. If you're listing 100,000 secrets, it's going to serialize those 100,000 secrets to Proto or JSON or whatever. Then it's going to stream that through the Gzip writer. So how you figured out it was like a 30-second delay on compression, because the compression is actually streaming. And so that might
you might accidentally have measured the network response time in addition to the compression time.
Correct. So both are tangled in that, like, we only have trace for how much time it takes to write response, and Gzip happens hand in hand with the response. But what I did though was I kind of patched the API server. So I tried to reproduce the same setup on my own cluster, and I tried to patch the API server to not do that Gzip compression, like set that threshold high enough. And the same call, now it runs like the etcd, the time it takes to list from etcd still remains the same, but the time it actually takes to send the response, it actually got reduced by like something like from 30 seconds down to 10 or 12 seconds. So which maybe
I'm skeptical. Like, I could see some artifact where if Gzip is in the chain, you're measuring time to last byte sent, but if it's not in the chain, you're measuring time to last byte encoded or enqueued. If that makes sense. Also, maybe Gzip like flushes more frequently. I don't know. Did you measure this from the client's perspective or from API server's perspective?
This is from the API server perspective. I look at both the traces and the metric for the response latency, like request duration.
Yeah, I'd measure this from the client's perspective. I generally find that network stuff is pretty hard to be sure about what exactly you're measuring, and it's easier to be sure if you measure like time to last byte from the client.
Okay, yeah, let me also measure on the client side. Yes, let me do that.
It doesn't make sense to me that you would turn off Gzip and a large request would get faster. Like I don't know what speed your network is, but like if it's not CPU, and it's not even CPU loaded, I don't know. Something doesn't add up to me.
Would that really convince you, Daniel, or do you really want something where like some sort of sync for this Gzip writer has a rate associated with it, and you get some sort of a benchmark test? I'm trying to think what would convince me that it's actually better if you disable Gzip. It seems like the client test would be highly dependent on what else was happening on that server when you were testing it.
Yeah. This is going to be pretty tricky to test. Could be, especially since, like Jordan says, we're mixing together the network send and the Gzip encode step.
Could a synthetic sync, on the other hand, a synthetic writer, so instead of sending it out, some sort of benchmark test?
Yeah, benchmark. A same system benchmark is going to not include any network latency.
Well, but you could have the sync act as a throttle, right, where it lets through a certain number of bytes per second.
Yeah, maybe we could have some sort of fancy copier that copied at a maximum rate.
I'm just trying to think, like, would that result convince us about the expense of Gzip?
Yeah, I think you should be able to do some sort of test setup like that.
So actually, maybe let me quickly mention the setup I did. So what I did is I took a pretty big box for the client from where I was making these calls, and the server also big box, like large CPU. They have very, very high bandwidth machines as well. And what I did was create like 10 different clients on the client instance, and then in parallel make these so only list calls, and they're jittered, so you don't all make this at the same time. And then with some throughput, you are continuously making these calls. So it's a sustained throughput. And on the server side, what I'm measuring is the network out bytes, which is how much response is being sent. So I can see that got reduced by something like 30 to 40% for secrets. Again, we should talk about how much it generally helps for different objects. Depending on the entropy of the data, it's different, but I took like base 64 secret data, right? It's just typical, or maybe config maps. And then I measured network out, I measured CPU as well, and I measured memory as well. I should probably document all of this. I'll do this in an issue after this call. So what happened is there was a CPU drop from something like close to 70% down to 20% on, this was on like a 32 core box, which where I was making parallel calls with throughput of 1 QPS, essentially 30 parallel workers making these calls.
On your 32 core system, does 100% mean using 1 core, or does 100% mean using 32 cores?
Yes, it means 32 cores. Yes, correct. So this was actually this is a EC2 metric. And so just to be sure that it is actually Gzip, I even took the CPU profile. And what I see from the CPU profile is like with Gzip, like a really huge part of the CPU profile goes into this flate. I think flate compress. I guess flate is the package which
Yeah,
Gzip
flate
uses
is the thing behind Gzip. Yeah.
Yep. So that's the one which actually eats up a lot of the CPU cycles. And when I turn it off, it's not there in the profile anymore. And yeah, the profile also shows how many in 30 seconds it measures. It checks how many cycles are actually used, right? So that also fell down.
I think it'd be good if we could get somebody on different hardware to like if you could.
Yeah.
If we could get someone on different hardware to double check and see if they get the same results, because I'm pretty sure we captured some sort of metric before turning this on, and 70 to 20% CPU usage seems pretty extreme to me. I don't know. Does that sound right to you, David or Jordan?
So one thing that just I want to clarify, Daniel. So in this cluster, I was only making list calls. So it's a pretty skewed workload. A typical cluster won't have only list calls, right? It'll have a lot of other things. So just to get this effect clearer, no nodes, no workloads, just create objects and list them. That's it on the client side.
Sure. There's also the question of like, what kind of network did you have between these two boxes? Because I'm not sure all networks can max out the CPU before they max out the network.
Yeah, so I guess I think generally what I'm trying to say is I'm not saying Gzip always hurts or Gzip is always good. I'm saying there might be value in us making this configurable on the API server, especially like in a lot of cloud provider settings where you have commodity hardware and like your network is usually pretty good within, especially within the infrastructure of the cloud provider, right? Like within VPC to VPC. It again depends, I think, also on the size of your clients, of your worker nodes, right? Like they may be really small burstable kinds of instances or maybe big ones. But
so I've also seen cases where users like the last mile, like maybe their ISP isn't good or something like that, and like they can't get a list response in the 60-second global timeout. Because I mean, the response is big, but the main problem is that their network is just slow. So API server CPU usage isn't the only factor there.
Okay, yeah, definitely. I think it's a combination of multiple different things. I guess, okay, so I think at this point, it's on me to post some of these findings under a ticket, and then maybe like you're saying, we can follow up with a different hardware, the same setup. I think, I guess the ask I have here is what would be a compelling case to actually, even though we don't change any defaults with Kubernetes, to actually make these configurable through flags, especially the size of the response at which we start compressing, as well as the compression level, which I think we default to 4 today in Kubernetes. But
I think I'm going to be hard to convince because of the case that I just mentioned, that you could have a client on the last mile with a slow network, and turning off gzip compression means that they can't get the answer in a reasonable amount of time because the network's so slow.
And a benchmark would help you there, right? So
Yeah,
there is a threshold for me. I mean, I'm not going to say there is no threshold for me, but it's also going to be significant, right? So if it's a threshold where any flag we add, we owe it to a cluster admin to explain when, why, and how they would turn it on for their situation. And the information that you shared here, at least verbally, I'm not seeing enough for me to be able to tell somebody, you should turn this flag to that value when this is your CPU and this is your network and this is what you're observing. I don't see that.
Yeah. I'd be, I mean, the bar would be even higher for this, but I'd be more inclined to go for something that like is measuring CPU usage versus network bandwidth and makes reasonable choices like on the fly like that. But that would even be a harder sell because that's going to be much more complicated. But yeah, I don't know that it's reasonable for system admins to be setting this, because I don't know that it's reasonable to have a setting for the API server as opposed to a setting per client. And clients can already control this by saying whether they accept the gzip encoding or not.
Yeah, there's actually a disable compression option in the
Yeah.
REST client config. So if you have a client you know is making big list requests, and you know in your scenario it's driving unacceptable server-side CPU use for some reason, you can make those clients not like, and you know from the client side, like I have a super fast network, like I don't care, send me big network requests. You can, from the client side, say I don't care about gzip. So
yeah,
let's say I had that for, I wanted that for my kube controller manager. Is there a way for me to configure that in my kube config today, or for the kube controller manager in general?
let me look.
Yeah, there is a flag for kubeconf, and we turn it off specifically for flag in the kubeconfig for which we turn it off for the kube control manager and scheduler. I think Clayton made this change a while ago.
Okay, Thaddeus is reminding us that we're at 20 minutes in. I think we know what the next steps are here. So
thanks
for,
though. I'll follow up on the findings.
Yeah, great. Yeah, I just want to make sure there's time for Kevin and Ratio. Kevin, do you want to?
Yep. Can you all hear me? All right, sweet.
Yep.
So I'm going to share once the other participant disables share, I think. Okay, cool. So if you remember last time, I came in and I discussed unions, and unions are this idea that there are going to be objects that or types that have multiple fields, of which only one of that grouping of fields can be set at any given time. And the kind of conclusion from the last meeting was that there's really kind of two categories of these, or two ways to approach this that we're kind of thinking about. Using a discriminator. So this is, if you look at the Kubernetes type of metric status, that's a good example. You can see what a discriminator is, where you have all these fields, only one can be set, and you also have a separate field that says, hey, which of these could be set? The other way is to do it without the discriminator. I had proposed doing it without, and then the feedback I got was, hey, look at all the possible test cases of this, see if that's still the case. And in the past 2 weeks, done that. The data seems to show that, yes, a discriminator is actually super useful, and there's a lot of test cases explaining why that is, and it kept that kind of details the whole design. Some of you have already looked at it, and that's awesome. And I think so. Today's goal is not so much an overview of the design, but to kind of discuss some of the open questions from that design. So if you haven't checked the KEP out, please do. Otherwise, these questions might be kind of out there. And so these open questions kind of boil down into a few categories. And the first of which is for some of these cases where there's different behavior, where we could behave differently based on, I'll just go through question 1. So there seems to be disagreement about what we do when the discriminator is set to a valid field. So it's pointing to, hey, one of these fields should be set, but the actual object doesn't have any of those fields set. And the case where this might arise is when a structured client, sorry, let's see, for 22. I didn't want to open up the matrix. Okay, so in a
As you can see from this table, we did our homework this time.
I was gonna say, I do love a good table, and this looks like a good table.
This was like a 2-hour table to read.
Yeah, well, it was a 2-week table to write.
What is the matrix?
sorry, what's that?
No, I'm just being snarky.
Yeah.
A structured client and a v2 field was added, and the structured client deserialized and did not want to change the union and then made an update call. And that would result in the discriminator remaining the same and the field being cleared. But it could also happen if a client was doing the wrong thing and you had an OC edit that deleted that line.
Yeah.
What do you mean by OC edit?
Oh, sorry, an
Keep going.
unstructured client that intentionally deletes the discriminated configuration, the v2 configuration. They intentionally delete it and then send that update. The request, I believe, would look identical to the server.
Yes, in both cases, the client has done something wrong, but in one case it's an error of commission and the other it's an error of omission. So I agree with the principle that if we can't distinguish, like if there's multiple ways a client could produce an invalid request, then our only option is to fail the request. Sorry, go ahead, Jordan.
Oh, sorry. Yeah.
I forgot what I was going to say.
Kevin?
Yeah, and so the alternative to what you're saying is that instead of erroring, we could just basically revert to the previous state that the object was in. And I think there was some disagreement on what we should do, but it sounds like, and the reason, I guess the reason why we might want to revert to the previous state is that there was concern about like breaking clients that wouldn't have otherwise broken. Is that correct, Daniel?
It's nice for old clients to have their stuff continue to work in the face of new fields that they don't understand. But we can't do that at the cost of causing problems with other, like auto fixing and misunderstanding other clients. In this case, if we knew which kind of client it was, we could figure it out, but I don't think that's the kind of thing that I want our updates to be smart about.
This is also sort of an odd scenario where like the object was defined with new fields by some client that understood those new fields, and then a structured client that wasn't the originator of this object is like wanting to do some other like read, update, write. Like even union stuff aside, like it could be dropping who knows what from this object, like trying to be clever and say, oh, we're going to copy stuff from the.
Yeah, the best way to fix this problem is for this client to use server-side apply and touch only the fields they want. That's a better solution.
But when that happens for a union, and let's say I have, again, V2 and V1, and I have an old client who has read an object and decides it wants to set the discriminated value to V1, and it sets a V1 configuration and sends that as an apply. does the v2 field get cleared in order to make that request succeed?
If it's in an apply and they set the discriminator to the new value and they add the new value, but they don't clear the other thing because they don't know about it, I think the apply, the server-side apply logic should automatically clear when you do that.
I agree. I don't know what the logic does, and I don't remember seeing it in this cap.
We don't, this is perspective, right? Like we don't have server-side apply handling discriminated unions today. We're trying to
There
set-
is actually an implementation in the structured merge and diff. Is that the right? Yeah, I always get it confused with strategic merge patch. The structured merge diff library has union logic that is currently disabled and probably needs to be relooked at in light of this cap. At any rate, it seems like we're in agreement that the answer for question 1 has to be A.
Yes, I think so too.
Okay, let's continue.
or at
Yeah,
least-
well, David.
or at least not B. Not copying stuff from the old object to the new object. Does A allow for optional union member fields? I'm sorry if this was previously discussed and I wasn't there for the discussion. I know, so for an example, some of our sort of pseudo union types today have like a rollout strategy that doesn't actually have any parameters. And so you could say like the rollout type is, you can just indicate the type and there's no associated field.
Yes, that's why it says null here and not unset.
Oh, no. I do not want to distinguish between null and unset.
I don't think we have a choice because we have unions that exist today, which the option of the union is just an empty struct.
That's saying we can't distinguish between null and unset.
No, whether it's present or not present.
That's different between null and unset.
Null and unset are identical.
Okay. Sorry, I'm using the wrong words. Null and present but empty. That's the.
Okay.
Yeah.
Those two can.
That's
be
the distinction.
But I don't think we can distinguish. I do not think we should distinguish between null and unset.
Yeah. I agree.
Null and
I'm
unset
sorry.
are Okay. Thank you.
Not enough sleep.
Yeah, I think Jordan, to answer your question, I think we do discuss optional versus required. I think for this specific case that we're talking about, my understanding is that the discriminator would be empty if you want it to not have any, if you want it to not be set.
The member field, not the discriminator. The discriminator would say my type is foo, and the member field foo would not have a value. Like for an optional member field, that could still be okay. This is question number 1 is trying to say, what do we do when it's not an optional member field? Like, do we error or do we retain?
Yeah.
So for non-optional member fields, I agree, we should error.
Okay. Yeah, and then for question 2, David just described it towards the end of the discussion, which is when a older client receives a field or receives an object with the newer field set, but it wants to set the field it knows about, the old field. So now it has 2 fields set, the discriminator set to the old field that the original client knows about, and then a client attempts to apply that. And so what it's applying is an object with both fields set, but the discriminator pointing to the older one that the old client is aware of. Should we clear the fields that are not pointed to by the discriminator, or reject the request, or not clear any of the fields, which I don't think is possible. I don't think that can pass validation.
Yeah, I don't understand how B is an option here. I don't think that leaves a valid object, so I don't think that can be an option.
How you do it with apply. So for apply, I think you're saying you do accept this request. Well, I guess you clear the other field. Okay. But I think that's different than what we want for an update.
Is there any ambiguity at this one? Like the client changed the discriminator
So is
and
it required?
added the corresponding option. I think it's pretty clear that what they want to do.
Are we requiring the discriminator to change to get this clearing behavior?
Yes, I think so. That is.
No. If you don't change the discriminator, but you add a new field of the union?
That's always an error.
Okay, yeah.
But if you do change the discriminator, then your intention becomes to set the field that the client knows about, but it shouldn't be responsible for clearing any fields it doesn't know about.
So this is an operation that's done on an update or an apply. Like I'm counting an update that isn't done via apply as an update. So this is only done when we have an old object and a new object to compare. We would look at the discriminator. Right. Did it change? And if so, clear old fields that are not matching the new one?
I think that's what David or Daniel and I are proposing. And I think David had some concerns about clearing the field in this case.
Yeah. Although the user's intent, way you put it, the user's intent is clear. That's pretty convincing. So yeah, I could see clearing the field except for the one chosen by the discriminator. So that would be C.
Yeah, I think that's how the logic has to work anyway.
It's typically limited to updates that are modifying the discriminator. The case that I would like to avoid is someone accidentally constructs a bogus manifest that like sets the discriminator to foo, but then also sets the foo and bar fields, like they're confused for some reason. And like, if they just tried to apply that and created the object, it would be unfortunate if we accepted that and we're like, yep, we'll clear bar, no problem. This is totally fine.
I agree. It should be an error on create.
Or an error when the discriminator isn't changing. Like if I tried to create,
yes,
and then later like updated my manifest and also set bar and then tried to update and like the discriminator didn't change. It was foo, it still was foo. I'm setting foo in bar.
Yes, I agree. Right.
Yeah, I think that we're always gonna err if multiple member fields are changed, right? Because this only occurs when one new member field is added and the other member field comes from an existing thing that was
Jordan also wants an error if the discriminator doesn't change and the existing option doesn't change, but a different option is added that doesn't correspond to the discriminator. That's an error.
If the clearing behavior is only done when the discriminator changes, then like the clearing behavior happens in update where we have old and new object. And then if it didn't change, we don't clear, then it goes to validation. And it's like, oh, you have two objects. Like this is just bogus. So that keeps us sort of in this layered approach where validation is the final word. And we do some helpful things on update when we can determine user intent by whether the discriminator changed.
Yeah, did we have I don't know if we had invalid requests in the table. If so, we should have had a request with more than one option selected in the table, but I think it's clear what should happen. We're running short on time, so let's keep going through this list.
So questions 3 and 4 is about the semantics of the actual Go markers that we're putting on the objects. And so the first one is, what should the value of the discriminator be when no union is to be set? Like in the case of what we're calling optional unions, when at most one of these fields must be set, as opposed to required where exactly one field must be set. Do we mandate that the discriminator is an empty string for all unions? Make the field specific on a per union basis where you have a separate Go marker to define like what the empty value is of the union, or mandate the discriminator be unset. Daniel, I think you might need to explain this one because I don't know if I totally captured your thinking.
Unset or null.
Maybe we're talking about two different things by optional unions. I'm envisioning things like our update strategies or like a volume source type where there's no additional information needed other than just the type. So like volume
No,
source,
that's not what this is about. This is
Okay.
about like, say you have 3 options in this union. The question is, must you choose one of those options, or may you choose none of the options? And so this is
That's maybe
in the
same
case
thing,
where the
though.
union is such that you are not forced to choose an option. What do you represent that as in the discriminator?
absence of the entire
Discriminator. So you choose option C. I don't know. Do you have an
Not
opinion, David?
discriminator, not just
I prefer the discriminator to be empty string so that we don't, I prefer the discriminator to be empty string so that we can require a choice
You require a deliberate choice
of nothing. Yeah.
Maybe I'm mis-envisioning what you mean by this. Do you have like a sample snippet of like JSON for the 3 options? Because
here. If you can stop scrolling for a second, I can maybe describe it. You've got one. Okay, never mind.
I mean, we don't actually have a JSON snippet here though of what it looks like to set but so basically you're going to have a JSON with, union type, field A and field B. And if, this one, if you can either have A or B or neither A or B, then in the neither A or nor B set state, what should union type be? And
Yeah, I'm with you, Jordan. I think it's the same thing.
like
as the update.
wherever this union struct is referenced, like the parent field that would be referencing this, I would expect it to be entirely unset. Like I don't know what it means if there's no type and there's no A and there's no B. Like just omit the whole substruct, right?
So there can be additional fields within this. Sorry. There can be additional fields within this struct that aren't part of the union, is kind of where it gets tricky. So we didn't see a whole lot of value in mandating the union struct be separate because we have a lot of existing cases where the union fields are kind of peppered in with fields that are not part of the union. And so in that case, the object will be here because it'll contain other fields, but we still want to indicate that neither A.
Empty string and absent for the discriminator field doesn't seem that.
So it would make a difference if we wanted to retrofit discriminators into unions that don't currently have them. Like, I don't know if we can reasonably add a required discriminator and have clients be okay with that.
You can't retrofit a required discriminator. It'll
Which makes me think that if we want to have any chance of retrofitting at all, the discriminator itself needs to be optional.
Are we wanting to retrofit this? I remember when Antoine and I talked about it.
I'm not sure. So that was also a comment that had multiple comments on it. I think Daniel asked for a migration plan. I wanted to know whether we can just do it from now on.
My my requirement for alpha is that we we do this for at least one field, one union of each type, just to demonstrate that the design actually works and we haven't missed something amazing, which is a thing that can happen in a design like this. I don't have a particular opinion on whether we should migrate everything. At this point, I'd like to keep the option open. But the real reason for doing at least one of each type is just to make sure that our design actually has real world usefulness.
Could we instead have a required E to E matrix that requires one example of each type get created and run through the equivalent of your table, or of this awesome table? I don't know who wrote it. Applied to it to make sure that it works. Could that function instead of trying to migrate existing cases?
I mean, that sounds good too. Why not both?
The thing we ran into, like a lot of what we're saying about user intent sort of falls apart if the discriminator fields are retrofitted and then like derived from the union member fields. Like it becomes circular. It's like, oh, we can tell that the discriminator should be this because they set this member field, and then we can tell the user intent because the discriminator is this value. Like it got super squirrely.
Yeah, that's also why we failed with the proposal like 2 years ago. And in the meantime, people have continued to make unions that are terrible because they don't have good guidance. And so I would rather have a good guidance now than fail to get this in.
But I agree that with Daniel that we want to exercise it. I think we could exercise it with tests of newly defined types, one of each flavor and all the interactions in the table. I think we should exercise them all to make sure we're not missing.
I guess if I unpack why tests feel insufficient to me, it's that like the same group of people are generating the tests as the code, and it's very easy to miss a case or like subtly test your feature knowing what your feature already does. Like the people who put the existing unions in the code base had no idea what we might do in the future. So I feel like they're going to be uncorrelated with the design in the same way that like real world authors would be uncorrelated with this design. And therefore it's a better test of whether it is going to function in reality.
Yeah.
But yes, if we just took literally existing structs and shoehorn those into tests as CRDs, then that's probably sufficient, I guess.
Okay, so is that the conclusion then for 5, that we want to exercise the migration via tests and not actually block the launch, the graduation on actual migration of actual types?
I can live with this for alpha. I may want to revisit the question for further stages, but
Cool.
maybe
And
it'll be
then
awesome and not.
Yeah. For 3, I guess that makes the answer for 3 kind of moot. I think A or C are both equally simple, right? Is that what that means? Like we could either do null or empty string, but
no, I think David's point that I think David's point is a good one. But if I go with that reasoning, then I think the question is between A and B. Like I could see somebody wanting to have their no option be like the string none or something like that. That seems even clearer than having it be the empty string.
Yeah, I guess one argument against that might be that it's harder for somebody looking at a new API to know, is none one of the fields in the union, or is it the null, the empty condition? And it becomes, I have to learn every field's discriminator
I would ask,
value.
are we wanting that to trigger clearing behavior? Like, are we wanting to be able to set the discriminator to a value, which means clear all member values?
Yes.
Yes.
Seems like empty string makes that easiest to me.
That's really subtle. Empty string and absent, unfortunately, get confused a lot.
Yeah, I don't think we can.
Empty string would make it. Empty string would make it not optional, right? It's required.
Right. Yeah.
And or defaulted. So if you try to omit it, then you get the empty string in the clearing behavior. On the other hand, if we chose C and somebody entered an empty string would not be a valid choice for this field, and they would get a validation error. So I don't know if that is a huge difference.
With the structured
we could
class,
also.
Can you even unset it?
Yeah, I was wondering about like, how do you express C in apply and patch and like, do you send
there's two ways in apply. If you already own the field, you can just omit it and that will clear it. The other way is you can deliberately set it equal to null and that will unset it. In a patch,
You also
a patch, you'd have to deliberately set it delete it. I think our 3 patch formats have slightly different syntaxes for doing that, but I'm pretty sure you can delete fields in all of them.
Yeah,
If you can address them at all. but apply is just easier.
So for A,
the other choice here, which isn't,
does that mean it has to be a pointer instead of a string? Or
yes, it would have to be a pointer. On the other, well, or we could interpret empty string as also meaning unset. I'm not sure how easy that is in the decoding path. The other option, which isn't listed here, if we have no plans to retrofit, then we can tell everybody to put these inside a union on their own, or inside a enclosing struct on their own, so that you just leave the whole thing unset, like Jordan was thinking originally.
We
I think
have
that will,
some discriminated unions where an empty string is interpreted as no opinion.
And it
And
gets
no
default.
opinion does not mean default. No opinion means no opinion. And so what happens is up to the system. Do you go down path A or B? It depends on what the current best guidance is. If you need behavior A, you better specify A. If you need behavior B, you better specify B. But if you just trust us to choose the best mode of deciding when to compress, then you just leave it empty and we choose that for you.
I would treat that personally as a third option, which is I would treat that as an optional union, right? If you don't choose a thing, then you get whatever the system does. But that's not a choice in the union. That's the lack of a choice.
Well, it's exactly what an optional union is, right?
Yeah. So you're saying that you already have unions that follow rule A.
Yeah. And doesn't mean they all have to be that way, just that like real world use case, that's what we decided to do. And it's worked pretty decently.
Another option we could have is both A and C.
What? How can it be both the empty string and be unset?
We could treat those the same way.
Oh, okay. Or D. I like including D, which is have the union be its own struct and just omit the entire struct. For guidance, if I was giving a recommendation for like a new API, that's probably what I would recommend instead of getting.
Yes. Okay. Let's finish this offline. Can we do question 4 in 2 minutes?
Yeah, I think 4 we can probably take offline too, because this is just what do we want the field name? How do we want to default if you don't provide when you want field?
How do we
A,
represent How do we represent the field name in the string that's stored in the discriminator? And seems like the existing ones that we already do use upper camel case. So I think we should go with that unless anybody objects.
And do you want to provide the users an ability to define their own way if they want to do it in all caps or something, or no? Should we not give them an option?
So
I would let them define it.
A.
Yeah, we probably have to.
First letter uppercase is the default.
That's the default in Go, but I think converting from lower camel to upper camel is not that trivial. So we should probably let people.
URL something or other, or yeah.
I think we should probably let people define it. Not necessarily for the Go types, but for the CRD, for the entry in the OpenAPI schema.
Yeah, okay, that's simple enough. All right, awesome. I appreciate it. That is super helpful, and I'll follow up offline individually with anything that
Should we require that the type, the discriminator value be case, be identical to the ruled, ignoring case?
What if people have 2 fields with the same name in different cases, which is something you could do in a CRD?
Like don't do that. It hurts when I poke myself in the eye.
Okay, let's take this offline. So I don't know do we have enough time to get to the last question that looked kind of big?
The last question was the
Huh?
migration one. I thought we talked about
Yeah.
modeling. the
Sorry, I meant the
existing-
last question on the SIG agenda.
Oh,
I do not think we're going to figure out whether we want to migrate in 8 minutes.
Okay, Kevin, do you want to stop sharing so I can share the screen again?
Done.
Thank you. Okay, let me share. Looks like Mauricio is adding more information real time. Well, we have 7 minutes. We need to stop at 12. So maybe we get started as I figure out how to share my screen. Mauricio, do you want to start? I think at least I know David and Daniel read the details of your question, but you can give an overview.
Okay. So this is Mauricio from SIG Storage. And in the company, we came across one security vulnerability report that is the first link, the second one there. And it's about what could be done with daemon sets that somehow have additional RBACs that they don't need, and what is their impact in the SIG storage components. So here I wrote a little bit about what the problem is and how we're trying to, and some ideas on how we're trying to solve it. So imagine that there is a cluster and one node gets compromised. In the image that is node A, by node being compromised, I mean that an attacker can somehow become a host or can execute commands from the host. And if the attacker can do that, then he can also make requests to the API server. For example, to create a PB somewhere else in some other node that is not compromised. And if the attacker is able to do that, then it's possible to have a scenario where the attacker that lives for now in node A can steal data from node B once a workload is scheduled in node B. So sorry, there is not a lot of info here about what these numbers mean. These are part of an internal document. But in summary, what we are trying to do now is try to restrict what an attacker could do from a compromised node by
sorry for interrupting since we have very little time. Have you talked to SIG Auth about this at all? Because I think that they may have thought of this and have something in the works. I thought I heard something about that. Also, I would say that it is the wrong place to, like, solving it for persistent volumes is not the right thing to do. You should solve this for everything. And it would be a shame if everybody went off and made their own solution for this, if that makes sense.
Yeah, that's right. I talked with Michael Toffen from, I think he's from GK Security. And
Yeah,
there are
okay.
plans to have a generalized solution that works for any component. But for now, the idea that we have is to add something. At least we could start with storage, and then if that solution works, then we can make it generalized for other components too. And the solution for PBs is to restrict where PBs can be created in the API server. So in this attack, node A is trying to create a PB in node B, and we are trying to disallow that by adding a webhook, an admission webhook. And I'm here because I was not sure what fields are available in the admission webhook request if we create this component.
yeah,
So
I can answer some of that. The information about the user making the request is sent to admission webhooks. And that includes the username, the groups it's a member of, and any extra info And specifically for service accounts running with credentials inside pods, the name and UID of the pod is included in the user info, like as sort of annotation type things. So you could identify the pod name and UID, and then look that up to see what node that was running on. There's also been discussion about, we have the name of the node as well. So there's been discussion about injecting that, but that hasn't been done yet. So if you wanted to consider that, that information is available.
Okay, I think we will probably have to defer this to a subsequent meeting. I am concerned about like doubling the load on the API server by checking this in against every object in webhook.
You can't stop them from doing it, right? This is part of a bound token, and the bound token results fill in the pod name and UID. And
no, I get that, but adding a webhook to then check this by making a lookup call with every mutating call doesn't seem great.
And you can look up the pod in a cache. That's what every other component.
Yeah, maybe if it's a cache, it could be okay. And maybe if it's not just persistent volumes, like I don't see that those are specific or are that special. So I would make it work for everything.
All right, yeah. Thank you. That's why I wanted to know. Yeah, thank you, Jordan.
All right.
I think we're almost at time. So Jeffrey, probably for the next time, we move your topic or we do it offline, aggregated discovery. Hope that is okay. And
yeah, I think that one was pretty close to being ready, and maybe just anyone on the call who wants to look at it should look at it. And if you have an objection, state it soon. Otherwise, it's likely to get approved.
I agree.
Sounds good. I want to thank everybody for coming today and meeting, and we'll see you next time. Take care, stay safe, have a good Wednesday.